Good afternoon. Good afternoon, everybody. The lecture is going to start. Can you hear me? Yes? Okay. Okay, before starting, let's go back for a very short recap on what you are expected to do at the exam, so that everything will be clear. And so I'm taking again the slides that I showed you the very first lecture. I remind you that the content is what you see here. Basically, we covered all fundamental concepts in data ethics. We will continue on some case studies and some other ethics and policy issues on the Mondays appointments. And of course, also with cases of biases in software systems and data, but not from the theoretical point of view. We already covered the statistical formalization of algorithm fairness, and we will reflect towards the end of the course on ACM ethics, ACM code of ethics and professionals. So from the point of view of the theory, we covered almost everything. We will do some other case studies that are part, of course, of the exam. I remind you that the exam, the data X part, is designed in a way that I can test, evaluate you against the following two goals: understand the consequences for people and society for when deploying an ADM system, and evaluate the risk or the impact of ADM systems, especially with a special eye on most vulnerable people. So you will get a case to solve that is in which I will basically evaluate you against this goal. And of course, you can usually, if you perform good here, you also perform good in the first goal, that is checked with a theory question. So one case with possible sub-questions, and a theory question with possible sub-questions. 7.5 points each. I remind you that is 45 minutes. No, you cannot bring nothing except blank sheets. And I also remind you that the threshold of sufficiency is for each question is 4.5, is the 60% of 7.5 points. Overall, in the exam, you need to have sufficient 3 questions out of 4, because this is an interdisciplinary course, and so we need. We decided that only having 18 was not sufficient, because you could reach 18 with only 2 sufficiencies, 2 questions sufficient, and then collecting some other points from insufficient questions. But this would not be coherent with the double nature of this course. So this is the rationale behind putting this criterion. By the way, this was relaxed. In the first 2 editions of the course, the sufficiency could be reached only if both parts were sufficient. Then we realized that it was probably too strict, and we found this compromise that I personally find quite reasonable. Evaluation criteria, 2 evaluation criteria: logical coherence and clarity in argumentation. It is very important. If your argumentation has a very poor logic, will be not evaluated with the maximum. And well, this is always correctness and precision of the answers. In all exams, this is present. Be aware that it's important that you remind that only if you answer to the questions, the text will be evaluated. And unfortunately, I always find quite a lot of exams in which there is a question and you answer with unrelated things. So I want to stress this point because it's important that you stick to the question. And also it's important to write a synthetic answer. The solutions that you will find starting from this evening or tomorrow that I will upload on the portal are written in a way that should help you understanding the case, but should not taken as a reference from the point of view of the length, because especially in some exams solutions, I tend to write a lot in order to allow you to understand as much as possible, but do not take that length as a reference. You should be concise, also because you have only 45 minutes. So you need to be clear, concise, and I can assure you that it is possible to be correct and concise and get the maximum. Okay. Yes, this is the very first appointment where we solve the past exam as exercise. What kind of exam you will of case, sorry, you can get? You might get a discrimination issue. And you might be asked to explain it, why a discrimination occurs, or to identify a risk. I ask you which risk of discrimination there is in this system and why. Explanation is always important, needed. You might get measurement issues that are mostly related to the process of the empirical process of measurement that in which we discussed quite a lot, both with a specific focus and in various cases we made examples of measurement issues. Often it's in combination. This is a sub-question in which I ask you one measurement issue or any measurement issues depending on the weight of the sub-question. You might have a case for fairness computation. Can be directly with a criteria of fairness, one of the 3, or some other kind of computations that basically are ratios, divisions, basic computations to understand if a discrimination occurs or if there is a risk of discrimination. So these can be in combination with discrimination issues. And then I might ask you also for suggestions for improvement. This is usually a minor, yes, I will then. Let me check if the camera also, yes. Forgot what I was saying. Yes, this usually is a minor, is a minor aspect. For example, 2 points, 2.5 points out of the 7.5. We'll make examples. So I ask you how given the discrimination issue that you explained, you just explained, how could you mitigate it? I'm assessing also your critical thinking that you should have developed during the course and seeing all the cases that we have commented and studied. Of course, you can get exercises and exams with combination even of 3 of them. Everything is designed to be solved in 45 minutes. So if the case is quite easy, in my opinion, then I might test you against more points. If I think that the case is quite difficult, I might reduce the number of sub-questions. So I will decide exam by exam. So there is no rule about that. Also because I always either invent the cases or many times I take real cases and I just simplify them and turn them into a solvable exam. Whenever I take inspiration from a real case, you will find always in the solution after the exam also the URL of the real case. Today, I selected this focus, explanation of discrimination issues. Do you have questions on this? Okay. Just wait a few seconds that the camera records this information for the recording. How today is organized? I'm gonna solve together with you the first exercise, so that you can try to follow me step by step in the reasoning and explanations. If you have doubts, you interrupt me. And then I give you the second, I introduce to you the second exercise, and then you have to solve by yourself. I will propose you a methodology that I found very successful. That is, I give you about 15 minutes to try to solve the exam by yourself. And then I ask you to join in groups, 3-4 people, and try to combine your own views and explanation, and so try to solve it together. And this is a methodology that has been proven both by scientific studies on methodologies for teaching, and by myself in past experiments with students in other exams where the answers were more quantitative. I could quickly verify experimentally that the number of correct answers after the group part was extremely higher, but only if the group session follows an individual session. Otherwise, the group session alone is not so effective. So this is what I'm I will suggest you to follow later. Then you are free, of course, to do it or not. Starting from the second exercise, there will be a student that will come and will help you answering questions. So 2 people every time can go around, and me and the assistant that can answer questions. Okay, I think we can proceed directly with the first exam. I should switch off the camera. And the very first case is that I already uploaded. Oops. The exam of 18 January 2021. I will never solve the theory part because slides, material, and the recording is enough. I want only to highlight that it's quite useless to build a glossary of questions, of past questions. You have access to all the questions, but questions change always. Also because I confirm only 80% and 90% of the content year after year. So the content is basically the same, but there are always variations because this is an evolving field in which we need to follow the last things happening. Also because, and the second motivation for which do not rely too much on the examples of questions, on the questions of the past exams, is that in the first 2 editions there was another professor teaching, Professor De Martin, which covered different aspects that are not covered anymore. This is a clear example because this year we will not do the Algorithmic Accountability Act because there was a new version, and I found that it was not. I want that this new. I want to wait that the new law proposal is a bit more stable in order to teach it. So I decided to remove the Algorithm Accountability Act, and so this is this year is impossible that you get such a question. Can be useful to check how I make the questions on the theory part, of course. I always ask you to remember something and then to show me that you understood. You see, summarize the main points. So here I gave up to 5 points because I thought that this was also difficult, and then 2.5 points for showing how you could use fairness criteria and bias measures that we are not covering this year for the prescription of the law proposals. Okay. Now let's go to the case. Prioritizing patients for intensive care programs. This is a real case that was simplified for exam, but everything was real. The health system of USA relies on a risk prediction tool to target patients for high-risk care management programs where identified patients are treated with additional resources. These programs are widely considered effective at improving successful treatment outcomes and satisfaction while reducing costs. Because the programs are very expensive, you need dedicated nurses, extra appointment slots, etc. The USA Health Ministry uses the risk prediction tool to identify patients who will benefit the most. So you have a tool that identify who should go to intensive care. This is the goal of the tool. To achieve such a goal, two key assumptions are made. Those with the greatest care needs will benefit the most from the program. Those with the highest medical expenditures are those with the greatest care needs. So there is this equivalence that is made. If you have a greater care need, so if you really need to go to intensive care, you also had more medical expenditures. You spent more money on medicaments, past medicaments. Is it clear? Because it was a central point. Under these assumptions, well, by the way, these were real. This was the real goal of the system. Under these assumptions, the targeted problem becomes a poor prediction problem. Predict future medical expenditures of patients. Because if you predict future medical expenditures, you predict, because of the assumption made by let's say the product owners, you also need more care. We have a goal that is the highest care need. This is the construct, okay? And a proxy is used. That is, can you understand my writing, or should I switch to capital letters? Fine? I'm trying to avoid this, but it's impossible. So we try to predict this. This is the target. The target variable. And this is the construct. Sorry, because there are some people following from remote that they ask to check the Blackboard. I make this exception. I will share again. Unfortunately, you will see most of the time my face, but I will try to make the board visible as much as it is possible to. Okay, I was speaking with your colleagues remotely. If this is clear, we can go ahead. Developers built the program, the algorithm relying on past data to build a predictor E with two parameters: total medical expenditures for patient I in the year T. So for every year and for every patient, I have well, I try to predict, sorry, for every year and every patient, the total cost, the total medical expenditures is my target. The algorithm is given a dataset with the following data on care utilized and billed to patient I over the year T-1, over the previous year. Demographics, age, and gender. Health insurance type, that is, can have two values: basic insurance provided by the state, by USA, or commercial insurance. Code of the main illness diagnosed. That is an identifier for a given illness. Prescribed medications, so this is a string, a list. Appointments made with type of medical service. It can be surgery, radiology, just a visit. And then the billed amounts categorized by type. Here are some examples. So all this is related to the data that we have. It is not known how these features were combined to make the prediction, so we don't know the model, the weights of the model. An independent audit looks at the algorithm results. So whenever you see an audit, it means that there was already an audit that checked the results, some results. And the algorithm's results, what are the algorithm's results? Are the patients identified for the intensive care program. You can approximate it as an evaluation test set. So data set with the results are already applying the algorithm, but not the training set. So one of the most common errors in this exam was a confusion about this table that was taken as the composition of the training set. But it is clearly written that these are the results of the independent audit, and it is clearly written that patients, what is the results are the patient identified for the intensive care program. So it's important that you read carefully. From the point of view of race, the published analysis results are reported in the following table, and we have 45,000 white and 5,000 black that are identified. Average age in years is 55.5 for white, 45.5 for black people. Percentage of female, 60% white, 70% black. Race composition of the intensive program, so it's 80% white and 20% of the selected is 80% and 20% black. So among the tests, these were the overall results. The results are on 50,000 people. And this percentage, and at the end, we have the 80%, just the set of the number of people, in the number of people that were predicted to go into intensive care, 80% were white, 20% were black. Do you have questions so far? First question, provide plausible explanation for the results of the audit. Clearly state your own hypothesis and any other information that you suppose in addition to the provided data in order to currently support your reasoning. You will find always this formula. Give an explanation and any other hypothesis that you are making or any other information that you think is important to make, that should be reasonable, you just present it. And then I ask you which data, which part of the process would you change to better achieve the goal of the system? The goal of the system is you should check at the construct. So identify those with highest care need. Now let's start commenting. Let's start from the table. As you can see, there is 80% of white people. Well, sorry, 80% of the intensive care selected people is white, and 20% is black. And this is, of course, the discrimination occurring. So this is a high disparity, but if you look at the number of people that were in the, let's call it the test set, for simplicity, this is about 10%. No, this is not about. This is 10%. This is 5,000 divided over 50,000 is the 10%. And this is the 90%. Is it clear? So the cause of the imbalance in the output could not be simply the different number of people that were the object of the classification, because the balance here was even worse. Is it clear? Because this is a fundamental passage. Yes, please. Yes. One second. I make a copy of the file so that I can write on it. So in total, we have 50, it was tested on 50,000 people. Okay? And if you make 45 divided by 50 is 90%, and 5 divided by 50 is the 10%. It's just there's no fairness criteria that is applied. It's just a consideration of the number of people in which it was tested. As you can see, then the number of the race composition in the intensive care program is even better. So because 20% is made of black. Is it clear? So this is just to explain you that the cause was not just the number of people present in the test set. You cannot use that information to explain any discrimination. take it in this way. If you had a proportional algorithm, just taking 1% of the black people, or 10% of the black people, and putting them in intensive care, 10% of the white people, putting them in intensive care, you will get exactly the same percentages. A neutral algorithm in this sense that will respect, will propagate the same percentages that you find in the test set. So this was just that's an explanation that I put, and you will find the solution, because many at that exam wrote that it's because of the imbalance here in the training set most, but this is not a training set, and the percentages are even worse in here. So you cannot rely on this information to explain the discrimination. This is the message. If this step is clear, I will go ahead. Okay. Let's start from my suggestion is, whenever you have an exam of this type, an explanation of a discrimination, that you analyze every variable and you try to understand every variable that is given, every feature, whether it is related into to the discrimination. We start with demographics, age and sex. Let's start from the latter, that is gender. We don't have any particular reason in this context, in this particular context, to say that gender is related to medical expenditures. I remind you that the discrimination can be only in a protected attribute, and in this exam, he was asked to explain the discrimination on ethnic group, on race. So here we have gender. And we leave it with no connections, with nothing else at the moment. The other is age. It is quite reasonable, instead, that age is related to medical expenditures. Person 20 years old, if not affected by particular illness, health problems, on average, we can expect that spend less. Okay? What I'm building here is a casual graph or correlation graph. It's a mix of the two. I put a minus just that you remember that there is an inverse relationship. The higher the age, well, I'm thinking in terms of being youngest. The youngest you are, the less you spend. Or in terms of age, the more you are, the higher is your age, and basically you can expect that the higher the medical expenditures. This is in general. Then look at the composition, and you can also see that female are more, average years, black people in the test set, not in the training set, but in the test set, are younger, 10 years younger than white people. You see from the table? If, and this is an assumption, if we accept the fact that we hypothesize that in the training data would somehow reflect this difference in age, that is actually also a quite a known characteristics of that population in USA. But let's stick to the text. If we assume that the training data would have the same difference, it is 10 years difference, is quite a relevant difference in this context, we might say that there is a weak correlation with, I call it race because it's shorter. This is valid on only under certain assumptions. But we can say that it could be possible at least. Then let's go ahead. B, health insurance type, basic insurance provided by USA or commercial insurance. This is something that is information that is well known, or at least we mentioned several times that the insurance type has a correlation with medical expenditures, because if you have a base insurance, many things are not covered. Many treatments are not possible. This is a well-known unsolved problems in that context in USA. Because insurance, as I often told you, is linked to the job and also to your economical conditions, health insurance. And this is given the structural inequalities that we highlighted several times. This is linked with race. So this is the first link, the first explanation that I expected that you mentioned. Insurance types is correlated with race, and insurance types determines the amount of medical expenditures because of the prediction goal, how this system has been designed. Do you have questions? Yes, please.
So the connection with the insurance side is that people who are poor cannot afford cannot afford good insurance, thus they spend less on
Yes. Yes.
medical care. And also about demographics, Agent 6.
Sorry, say again, please.
About the previous bullet points, Agent 6, you
Yes.
said that although black people are 10% of the total population, they have they receive 20% of intensive care program. So based on this, how you said it's not relevant?
I'm not saying that. I didn't say that this is total population. This is the population of the I called it the test set. Where the set of the people in which the algorithm was run. I'm saying that this is an explanation of why it's not admissible that you answer to the exam, to the first question of the exam, by saying that we have a discrimination in the output because there is this imbalance in the training set. First of all, because it's not a training set. Secondly, because if you make the percentages, these percentages, so this output is even better than those percentages. I made this explanation because this was a frequent error in the exam. There was another question behind. Yes.
Aren't other races included in the test population?
No. If I don't put other races that in groups, you just stick to the data that is provided.
So we suppose that in America there are only one.
Yes.
Okay, thank you. When you connected, you said issues type and race are connected.
Why?
Why?
Because of the socio-economic conditions related that is much lower in general, on average, to black people. We spend a lot of time spent discussing this, and this this prevents you, to get a lower insurance usually, and so you spend less. If you want to predict costs, expenditures, here is the chain of. Yes, please.
Would it be wrong to assume that women have higher medical bills due to childbirth, for example?
Can you repeat? Because there was some noise. Sorry, over there. I cannot hear.
Would it be also wrong to assume that women do have higher medical bills because of childbirth? Like in the United States, that's pretty expensive.
Because of childbirth,
for example.
This is something cannot be the main cause. So under this very general context, I did not take into account that case. If you are able to, in the exam, if you are able to identify the main cause, and then you also mention that there is this possibility, maybe not as a main, but as a weak, let's say, correlation, I can accept. It depends on the overall explanation that you give. So we'll analyze.
The percentage of women is higher in both.
Yeah, but because here the number of possibility of medical expenditures is so high that you need to put the assumption that those types of expenditures are relevant in the overall set. So it's not wrong, but depends also on how you explain it, how you and whether you identify the main cause. Okay. Other questions? Okay, let's go ahead. Cause of the main illness that is diagnosed, prescribed medications, and appointments made are all related to expenditures, either directly or either via billed amounts. So what you will find in the proposed solution is that you have billed amounts connected with medical expenditures. This is connected with C, variable D, and variable E. There are some types of health problems that will require higher medical expenditures, that will require higher billed amounts. There are some prescribed medications that will depend, of course, on the illness, the code of the illness. Prescribed medications will also be highly correlated with types of with appointments made. But this is what you see in the right part of the graph. At least with the information attained at the exam, and even considering all the patterns of inequalities that we analyzed, we can say that we don't have particular reasons to consider all these variables linked to race. We don't have information. We should have some type of more correlational data to understand whether Black population is affected by, in a significant way, by certain categories of illness. So we need some extra information that we don't have. So we can safely consider that they are not related. Also, this is, but is inflation. Yes, please.
In my mind, I think it's very clear that if someone is poorer, the person will make less appointments and take less medicine. If you
think, depending on the way you express it and the overall logical reasoning, I can accept it. But the main driver here is that one. This is quite clear, and if you miss that one and you present only that link, is a bit poor as an explanation. So you will always you will always get the solutions as indications for a possible solution. So every solution that you get, a text that you will get after the exercises, after the exam, is proposed as a guide to the solution. Then I need to follow your logical reasonings, your own logical reasoning that you expose in the exam. There are certain elements that must be there, like the link with insurance type. Other considerations that were made here, they might be acceptable, but provided your overall reasoning and how you express them. This one, the one on maternity costs, so it depends on how you express them. You don't need to provide me, also because the exam is on the laptop, the whole graph. I make the graph to better explain the guide to the solution. Then, second question, which data, which part of the process would you change to better achieve the goal of the system? Well, here, it really depends on your critical thinking and capacity to make the imagination step. But examples of acceptable answers are the following. First of all, look at the construct and the target variable. There is a mismatch, a clear mismatch that caused the discrimination, also in the real case. If you measure highest care need with highest expenditures, you are missing your construct. So if you want to measure to predict highest care, you might, I mentioned in the example solution, you might check the number of active chronic or serious health conditions instead of medical expenditures. So a flag, kind of a flag on whether conditions are critical or the number of critical issues that you have. This is a medical information that is, you can think that is obtainable. You might also have a variable that combines the health prediction, the health status, with expenditures. You might also do not include, so do not get rid of at all to medical expenditures, but you should mitigate the impact. So building a combined index. But the important thing is that you should measure really the construct, that is health conditions. Then, since I also mentioned not only the data, but also part of the process, you could also reason in terms of information given to the doctors. For instance, not only giving a prediction, yes, no, eligible for intensive care, not eligible, but you can provide also side a box, informative box on what are the current health conditions, what are the most important or most common medical appointments, what are the most common medical issues of this person, so that the doctor, the final decision can be taken also not only relying only on a number, but also looking at contextual information. This is a possibility, an improvement that you could put in place in order to avoid or mitigate the discrimination issue. You have questions? Yes, please.
Isn't the last thing that you said already present in some way in the features, like prescribed medications, code of the main units, etc.?
Yeah, I stick to the information available. I didn't. So I just said that the output should not be only a prediction, but there should be also some contextual information.
Using this data.
Yes. Writing only as an answer to this point, removing medical expenditures is not enough. You need to propose something. In my mind, this type of question should help you in achieving a higher mark. And usually it is, but sometimes answers were too poor. I repeat what I already said. Do not over-rely on the examples provided, so do not overfit your preparation on the examples provided, because otherwise you might encounter problems. A slight variation in the questions might put you in troubles. In one exam, I made the same question, but the goal was not to better achieve, well, the final part of the question was not to better achieve the goal of the system. The final part was to be able to compute the separation criteria. Unfortunately, many people did not went in an automatic way, did not read the last part of the last words of the question and answered with improvement goals. They were not the question. So be careful on what I ask. Okay. My suggestion would be to go ahead and you organize yourself with the break, if you agree. So I present you the next text, and then I leave you some time to start doing it. And we can do like this. I present you the text. This is a proposal. I present you the text, and then I give you 40 minutes. 50 minutes you do it alone, 50 minutes in group. 10 minutes if you want to make a break during the solving exercise, and then I will solve it. That's fine, or you prefer to have a common break now? Who prefer to have a common break right now? Just raise your hand. Okay, you are the majority, so I need to revert my proposal, and we will start in 10 minutes. Okay? Okay, the second case, that is the exercise that you will do, is student success predictive model. Can you please take your place, because I need to start? Thank you. I will read it, explain a few things, and then you are left 50 minutes alone and 50 minutes in group. Here is Christian that will help me and you in answering doubts and during while solving the exercise. Okay. It was exam, the first exam of the summer session. Okay. The company abcsoftware.com, in short ABC, sells a service based on the student success predictive model, SSPM, to predict the graduation likelihood of university students in USA. So this is the target variable. Whenever you see to predict something, this is what you want to predict. So graduation likelihood. Once the software produces predictions, no further guidance is given to professors who serve as student advisors, and it is up to the school to decide what to do with predictions. Typically, the service is used by universities to recommend students changing major or to withdraw their career. So this informs you on the usage of this prediction. The tool outputs, the model outputs a prediction and says, Mario Rossi has very low likelihood, very low probability to graduate. Then the usage of this prediction is left up to the school. Most of the times, if a prediction is, let's say, negative, it's bad for the student, a recommendation of changing major or to leave university is made. But this is a human, this is the human part of the decision process. Predictions are made with a university-specific model. That means that the model is specific to the given university. Each university has its own model. A customized set of predictors is constructed from student records of the specific university and then combined and weighted using an automated training process designed to maximize predictive accuracy. Historical student records that are used in the training set satisfy the following criteria. Matriculated between 1st September 2005 and 31st July 2010, 5 years, and at least 3 registered successful exams passed. Yearly subscription taxes regularly paid. These are conditions for the data. Predictions are made on any type of student, either from incoming freshmen or to nearly graduating seniors. So any type of students can be object of the prediction, if you are a first-year student or if you are the last year. And the final rank is provided with success scores from low to high. Among the predictors used for training the model in University X, a specific university, the ones which had higher impact on the score of the software, that are responsible for more than 5% of the variances in scores, are the following ones. You can, this was noise, this information, you could also ignore. The important message of this sentence is that all the following variables had higher impact on the score of the software. Well, I'm already explaining you a little bit of the solution, but it's to help you. Because I wrote that the ones which had the higher impact on the score of the software. And you have a list of variables. This list actually was not what you got at the exam, because you got only half of the variables. There were 2 versions of the exam. In this exam, in this exercise, I provide you with all the variables, all possible variables. But each student at the time got only half of the variables. And then one of these 2 tables that you will see. So to solve the exercise, now you take into consideration all the variables. This is my strong recommendation. And then you select one of the 2 tables. They are equivalent. I designed them to be absolutely equivalent. And also the variables are designed to be, in the two exam versions, absolutely equivalent. And the variables are admit code, student admission type, which can be, these are the levels, the options for the variable, first time freshman, transfer from another university, conditional admit, documentation missing, for example. First generation indicator, yes or no, an indicator of whether any of an individual's parents have ever earned a bachelor degree. So if a parent of a student, one of the two parents, already holds a bachelor degree, this variable is yes. Hold at least a bachelor degree. Otherwise, no. Median income by admission, zip code. The median household income in the zip code of a student's home at the time of earned admission. So when you are admitted to a university, you also declare your zip code, and from external statistics, the median household income of that zip code is automatically translated in this variable. High school GPA, a student high school grade point average, your average scores at the high school. Legacy indicator, yes or no, is whether the parent of that student had a family or any other family member attended the same college. This is called legacy indicator. So if, imagine you enrolled at Politecnico and one of your parents studied at Politecnico, then this variable will be yes. Otherwise will be no. If it studies at l'Università La Sapienza di Roma, no, will be no. International indicator, yes or no. Indicator whether an individual is an international student. High school percentile, a student's high school rank in terms of percentile in that specific high school. So where the student was in the rank of the high school. High school size, the size of an individual's high school student body. So you come from a given high school that is very small, or you come from a high school that is very large. Veteran indicator, yes or no, whether a student is a veteran of the United States Armed Forces. In-state resident indicator, yes or no, whether a student is a resident of the university home state. So if you are resident in Piemonte and you enroll to Politecnico, here is yes. An audit found large disparities in the software outcomes for students of different races according to the following table. So different races, this is the discrimination. You have black, white, Latino, Asiatic, and you have frequencies. Success, prediction is success, prediction is moderate success, prediction is failure, prediction is unknown. And here you are provided with a table. We can agree that we all take as a reference table 1. Table 2 is equivalent, but we can say that you all now take as a reference table 1. Provide possible explanations for the results of the audit. Clearly state your own hypothesis and any other information that you suppose in addition to the provided data in order to currently support your reasoning. Which measurement issues do you observe? Do not do it now. We will do it together. And then do it. Which data, which part of the process would you change to make the impact to the system less harmful? This is part of your work now. One comment before I leave you with the text. And this was too long. This was way too long. So I adjusted a little bit the marks because I realized after the exam that I asked too many things. So don't take it as a regular exam, let's say. So don't worry, it will not be as long as this exam, your one. Okay. So it is important that you start analyzing the test individually and take some time and then try to solve the first question at least, and possibly also have a thinking to the third one. Let's do the 15 minutes alone. Well, this is my suggestion. Then after 15 minutes, I will tell you that 15 minutes passed, and then you can work in groups, and then we comment together. Just raise your hand, and Christian and or me will come. And I will stop the recording now. Okay, here is a possible solution, at least a guide to a possible solution that I will share with you now. And I'm using the questions that you make me and to make a few modifications to the prepared solution. So it will take me 1 or 2 days, just the time to change a little bit, to improve a little bit the text I will give you, and then I will upload the solutions. This is just to inform you about the timing on when you will get the solutions of these exams in 1-2 days, roughly. In the proposed solution that you will find, there is a guiding idea that is driven by this sentence. That the service is used by university to recommend students changing major or to withdraw their career. This is the decision that is made. How the prediction is used to make the decision. If you remember, I wrote you a formula that a decision can be, what can I write? A decision can be, okay, let me switch on the camera. Okay, when we formalized the problem of bias and the problem of fairness, we say the decision can be either a direct function of the classification. I take the classification as it is, or can be in function of a classification, maybe some protected attributes, and any other relevant variable information. So this means that the decision can be made directly, the prediction made, or indirectly, on top of the classification made. In this case, is a bit in the middle because the likelihood, the graduation likelihood, is used to recommend that you should change university or should withdraw. So it's used in a complementary way. It's used basically only when you predict a failure. This is what will guide the proposed solution. With this in mind, this is not the only possible solution. It's what you will find as what I propose. But this is the explanation of why I take into account in the table only the failures, basically. you could sum up basically success, moderate success, with a category that is R equal to 1, for instance. You could drop the unknown, or you can sum up to the success. It never minds what. It's most informative is the failure. There is no need to compute fairness criteria because it was not asked here. You could, in order to identify what are the disadvantaged races, because I tell you in the exam, as in the previous exam, I tell you that there is a problem, a discrimination issue. I don't directly mention what ethnic group is disadvantaged. In the previous exam there were only 2 ethnic groups and was pretty clear they were the black disadvantaged. In this exam, you need to understand who are the discriminated, who are the disadvantaged. They are the black and Latinos, basically. If you look at the failure, at the row of the failure, and one possible way would be to compute among the 2,800 and 800 predictions with failure, that roughly, if I well remember, should be 45%. Is made by black people. I'm using the row, just computation, the composition of these 2,800 people is 45% black, and it is 38% Latino. And the 45 is, just to make it clear, comes from this. This is just an observation. You could make several other computations as you wish, but it was the table was built in such a way that the discrimination should be clearly identified towards black and towards Latinos, because here we have less than 10%. Basically. The table was built in a way that the order of magnitude in black and Latinos was particularly different than the order of magnitude of white and Asiatic. So that it should be clear within a few, if not few seconds, in a few minutes, that where the discrimination issue resides. So having identified what are the disadvantaged ethnic groups, most of the difficulty, I think, it was solved, because we know that all these variables were related to the predictor, were relevant for the prediction. The text says it had higher impact. This was information that was given. What you had to find was the relationship with the disadvantaged ethnic groups. Admit code. Well, here we cannot find any type of correlation with ethnic group. The type of admissions is not related. First generation indicator, well, this is clearly connected, because if your parents, if this exam was given in 2021, it means that the parents of people at the university 2021 should be roughly in the 60s, roughly. Should have attained the university in the 60s. So we can assume that this is connected with the ethnic group because of the structural inequality. of attendance in US universities in general. And in the previous generation was particularly even more relevant. The median income, this is also something that is correlated with ethnic group. No assumption to be made here. The performance of a student is a given high school. We don't have information in the text, neither in the text nor in the trends, identified trends of inequalities that we saw during the course. So we will leave it as not relevant for the explanation. And this is similar to first generation indicator, legacy indicator, whether your parent was a family member, attended the same college. So whoever got variable B did not get also variable E. They were designed to be equivalent. This is the same reasoning is behind. So they were not in the same exam text. International indicator. This is something that is I was quite flexible in the acceptance or not of this criterion. I don't have information that this should be relevant to the ethnic group. Whether individual is international students, it says nothing from where, comes from the global north, from the global south, so is not relevant. It's not connected to the ethnic group. Then G, high school percentile. We don't have information to say some ethnic groups perform better than others. It is this variable is equivalent to high school GPA. So where again, who got variable D didn't get also a variable G. High school size, this was different because usually private high schools might be considered to be smaller, and so private schools cost more. And if you attended a private school, it might be correlated to ethnic group. And this is also an acceptable indication for explanation. This is a veteran indicator. I put in yellow because it is connected with ethnic group, because we have no particular indication for not assuming that in the army there is a majority of white people, because the majority of the US population is white. If you check the statistics also, is like this. If you check the official statistics on the army composition, is like this. However, is correlated to white people, not to the disadvantaged ethnic group. So I'm putting this in yellow. Maybe I should change color, because it's connected to ethnic group, but it's not an explanation, a strong explanation for the discrimination. But it is connected. And in-state indicator is similar, although complementary, to variable F. We have no, unless it is written that University X is in a state in which there is a specific composition of the ethnic groups, we don't have other information and any other general trend to say that this is connected with ethnic group, and it is a possible cause of explanation. So it was built, the text, in such a way that you had 2 indicators out of 5 to be identified. here you have the whole list, but remember that the exam was split in 2 versions equivalent. Of course, depending on your own exam, how you explain things, I tailor my evaluation. If you just put the name of a variable without explaining it, doesn't count. So if you correctly identify variable C, but you don't explain me why you put variable C as an explanation, a discrimination, doesn't count. Is it clear? There was a question on measurement issues that I told you not to do by yourself because I provide you some examples. A first example of a measurement issue is a possible aggregation bias, because the model, it is used to any type of student. It is written here. From incoming freshmen to nearly graduating seniors. And if you make a prediction on people that is very close to the graduation, the weight of some predictor is very different if you, in the case of incoming freshmen, incoming students. For the latter ones, for example, the indicators on the performances in high school could be stronger than the indicator for a student who almost finished the university degree. So it would be, for this context, it would be important to build different models for people entering at the first year, for instance, and model for more senior students, because the predictors can perform very differently given the context at hand. Another type of measurement issues is that you are using data from 2005 to 2010, which had also in the time span a big event, global event, that is the economical crisis of 2008, that could have changed totally the economic condition of people, and use this data from 10 years ago, that is trained with so you're training an algorithm with data that is 10 years old for predicting, so without using more recent data. So you might have an evaluation bias here. This is a measurement issue. Of course, it is also always valid, the fact that you're using group statistics to make individual predictions. So especially in this context, you might have that one variable might be particularly relevant for a given student, but not for another student. But this is always true. So using general patterns to make individual predictions is always a limitation. So you should be more specific when identifying measurement issues. So the first 2 issues that I told you are mostly relevant. So training data that is too old, inadequate for the task at hand, and subgroups that should be made, because you are predicting things that are very types of people that are very different. So you need different models, given also the information that is carried by these variables. And you could start from the measurement issues also to propose improvements to the project, to the system. And one consequence is that of what I said is that you should build different models. This is also one possible improvement of the system. Most frequent errors that were found in this exam. As I said, this was too long, so I adjusted the marks at the end. I raised everything a little bit. These are, so what you see here, the criterion for data collection are not predictors. So some people confused, took these criterion as variables and used them to make explanations. And this is wrong. The text said clearly that all these variables were relevant predictors. So saying that one variable is not a relevant predictor was not the question. The question was to identify among them those who were connected to ethnic group. Other frequent error is missing an explanation. So you identify a feature, you say this because of this, the discrimination occurred because of, let's say, feature C, but you don't explain it. It's not valid. This data that I give you is not the training data. It was the result of the audit. And answering to measurement issues with an explanation of a discrimination, no, this is not possible. So a few exams were repeating basically the explanation of the discrimination also in question 2. So measurement issues, we know that are different from discrimination issues. There are limitations of the model that you build, or the data collection process, etc. These were the most frequent errors. Okay. You have the text of the third exercise, a bit late, but we'll try. I still propose you. Okay, there are questions, yes? Yes. And why you should explain why it is a bad choice. A colleague of you previously asked me whether this could be also an explanation for discrimination. Depends on your overall answer. So if you point it as a main explanation, is not enough. Also consider that the US system is different. You borrow money, so you don't have to pay the taxes basically. But this is contextual information. So I could accept it provided you explain it well and that you identify the most relevant causes of explanation. So I'm a bit flexible, but it always depends on how you bring to me the information. Other questions? Okay, I make the following proposal. I introduce you very quickly the next exercise, and you start doing it. And as earlier, Christian will help you with questions. I will show you, if there is time, the solution next time. In any case, I will upload the solution because there is no time to do both now. So the next exercise is car insurance. I quickly read it. An Italian car insurance, also this was a real case. An Italian car insurance provider experimented the use of machine learning for predicting the risk of repaying the cost of caused incidents in a year for a person, for a given person. In case of high risk, a higher premium is offered to the applicant, who can then accept the quote or not. The company used part of its own historical data from 2010 to 2020 to train a classifier. During the experimentation, applicants could get their quote after filling a form with data about the car and themselves. Fields are the same used by the classifier. In addition to that data, applicants were required to input information in an ethnic group. Although this sensitive data was not used by the classification algorithm, it was collected to test the classification against discrimination. So the discrimination issue is on race. In fact, national and international regulations require that prices should not vary depending on the ethnic group, and they also forbid the training of classification prediction algorithms with it. So race is given as information by the user, but is not used in the classification algorithm. All the other information, yes. And the ethnic group had 3 possible values: Caucasian, Black, Asiatic. The features used by the classifier are birthplace, the driver nations of birth, the list of all possible countries in the world, age, driver's age, between 18 and 100, city, the driver's residence, where the driver resides, live in Italy, car, insured vehicle type, deduced from the car model and the year, and it has 2 possible values: small cars and large, powerful cars, only 2 levels. Claim history, number of previous claims with 3 possible values: less than 3, between 3 and 6, more than 6, and yearly distance, estimation kilometers driven in a year. The analysis of the data gathered during the 6-month experimentation showed that offered price varied significantly when only ethnic group differed, while all other characteristics were equal. This means there was a problem with respect to ethnic group. And therefore, the company dismissed the development of the system and blah, blah, blah. So this is not interesting. So provide a possible explanation of the results of the experimentation. Why there is a discrimination by ethnic group. And then which measurement issues and which changes in the experimentation data. In these 15 minutes that you have, just focus on the possible explanation. Okay? So you already have the text in the material, and try to think about it. Proverei a saltare la prima spiegazione, perché visto quanto sono andato lungo, mi ti chiederei di vedere al massimo finiamo più corto. Poi se vuoi venire un pochino più dopo, un po' dopo, abbiamo spesso. I will now close also the recording, and given that